Hello everybody, I'm Marco D'Ambros, and today we're gonna see how to dynamically change the paint weight of or the weight map, sorry, of deformer in Maya using bifrost. So if it's happened on your past, or like I'm pretty sure everybody has some experience where he has to use some hack to change the paint weights, or like normalize the weights of different maps on the blend shape and this sort of adventure. And that I think is normal, but since Bifrost I kind of changed my approach, and I start to use Bifrost to do this kind of operation, and even more, and I'm gonna show you right now what I meant with for more. Just like a small note, probably actually let me see some example and we can talk about this one later. So for example, here we have like a normal blend shape. So this is a blend, so of course this is a target. So this is a normal blend shape. We can activate, deactivate it. That is our target. So you can see we can move it around. Everything is normal. How you can see, both are on, the envelope and the mesh, but I can turn on and off with Bifrost. This is because we are dynamically change the weight map of our target. And I can show you some example like why can these things been useful. So for example, let's activate this one. I can activate by radius. So this is like a locator where I attach like a sort of, it's not a sphere, but like by radius I can activate this one when I go closer, and I can do similar things and use a plane. So if I turn off the radius, now this work as a plane, so I can turn on and off. Depends of these plans. Cool. So let's do like a small note about these things here. In Maya 2022, they changed the approach of the deformer, and they introduced two elements. They introduced the fall off element with the sphere and plane. So you can see this sort of approach very similar to what we have in Maya, but actually are not the same. So what are the difference between this approach and the Maya one? It's pretty simple. So there is a few reasons why you want to use one or the other one. So let's say if you just want to use like a radius fall off or a plane fall off, and that's it, I suggest to use the Maya one. Straight, very directly, and everything is integrated. There is like one limitation, that is work on Maya 2022, and like you say, now I'm on Maya 2019. So one reason to use this approach instead the Maya fall off is which version of Maya are you using? You're using before or after 2022. The other reason is we are literally implement the method within Bifrost. So this means we have in control of everything, every type of computation. We are writing the logic. So this means we have a full control of what we are doing. So even in Maya 2022, if you want to do a little bit more of what by default Maya gives to you, Bifrost is the answer for you. So sorry for this like a small explanation. I think it was like due to like why you don't use the Maya one, or you introduce these things here. That's it. I'm using a version older than Maya 2022, so I cannot use the fall off, and that is my choice. This is the same things on production where I'm in production. Even so, I like to have control. I like to write the logic, so I do prefer approach in this way. There are pros and cons, of course. Another reason, you can do operation with maps. So for example, I want to show you. So on Bifrost, I activate my, sorry for that, my maps. Yeah, sorry, change it be, I'll show you. So I have three maps here, map 1, map 2, map 3. First of all, I want to show you, I have just one target, but I have multiple maps. That is a kind of like a pro. I have three maps at the moment. So these two are added together, so we sum it together. And one pro, you can see, even if the maps are overlap one with each other, we don't have, we are still clamping the value to 0 to 1, so we never go like on 2 or wherever. So you can have maps then are more integrated one with each other, interact one with each other, and you can always have control on the output value. So if you in the normal Maya, if you have two blend shape, for example, to target with some vertex and overlap one each other, you're going to have the sum of that. Instead, working with the maps, you can play with this value. And the other things is like the third one, for example, I added here, this is just an example for you guys. The method that I'm using is a little bit more complex or advanced, but it's the same idea, just implemented, more implemented. So we have a multiplier. So this multiplier can even go like negative. And this mean with negative is mean we subtract. So if you see now, this is like a normal iteration. But if I go to negative, we subtract this map to our other two. So like you say, we can do multiple or different type of operation. We can sum different map, we subtract, and you can make this as complex as you want and more flexible as you want. So I hope I kind of convinced why this approach is interesting. So let's go and jump in and see how to do it. Let me open an empty scene. Sure. So these I just have the two geometries. So the first thing that I like to do is to always duplicate my my base object, and create a ref mesh. There is not like a lot of reason to have it, but I do like to create a flow that are separate. And I'll show you what I mean now with the connection. So I do prefer to have a ref mesh where I can work with, instead to use my base one. But this is just my approach. You can even use the intermediate object if you want to. Let's create a blend shape. Cool. So now I don't need this one, so let's delete it. So yeah, we have a blend shape 1-to-1. That is perfect. So let's create immediately. Let's go to create immediately the value that we want to have, like the base structure. So actually, okay. So let's create a empty input bifrost node. Let's bring inside our connection. So this is our bifrost. So first things, we want to connect our ref mesh. There are different type of point that we want. Let's say get point position. We need this one eventually. So let's start with the get point count. We can even use this one and count the number of output here. It's absolutely the same. So let's use the proper one at now, but you know, either way, absolutely the same. So now let's connect our out mesh. So let's find out mesh. I know the alphabet as well. Okay, out mesh with our geometry. Let's call this one. Let's call this one in ref mesh. Oh, sorry. Okay, bifrost here in ref mesh. Output mesh in ref mesh. So we want to create, first things, we want to create our base of values. So let's create a resize array. So we are going to create an array with the same number of these vertex here, with the default number is a value. Like we can actually connect this one directly to our input. So now it's 0. So now we have an array that is absolutely the same number of our vertices, and they're all float 0. Rename this one in out weight. Okay, so now we have our out weight. Let's get, this is the secret, and from that you can literally just play and find everything that you need. So let's get the blend shape. So we have our blend shape node, we have our bifrost. So we need to connect our resize array in weight, sorry, out weight. So out weight 0. 2, we need to go to inside our input target 0 depends on the array. There is another input. Don't use these base weights. Let's go inside the intergroup as well, and you have a target weights here. So let's select. So Maya, what does it do? It just select the first value with the first value. So technically we are just changing at the moment only one weight, one vertex weight. That is not like a big deal. What I suggest to do, if you open, you can, of course, you can already write your own line. That is fine. But if you are lazy like me, you can literally connect this one. Just double click, delete this one, and you can just remove the array. In this way, you can connect the directory attribute. If you see now, everything is connected. Yeah, you cannot do on a UI, so you have to do manually in this sort of way, or directly write the code. But that's it. So, and you can see we already have our result. So everything is 0, and the reason is our default now is 0. So at the moment we didn't do nothing, so we can go negative and more plus, etc, etc. So the first thing we want to do is just add the clamp value from 0 to 1. This is optional and depends how you want to approach it. You can even input this min max, so you can manage inside your node, etc, etc, etc. But now that we have it, we go to 0 and 1. Cool. So let's do the first example, that is mean using locator, and do like using to create the plane or the sphere with the distance, either way. So so now we have our locator. We want to, well, we need to have our point position, because now we are working with point position. We want to have another input. You can use, of course, this input here. I like to keep separately because it's giving me like more cleanness if you want to. So let's get matrix to SRT. We connected, so now we have the input for our locator. So we can get our. So first things I want to show you, actually, with the ref mesh I use auto mesh and not workspace mesh. So I want to work with origin, and if you want, you can do the extra multiplication to work always on the origin or bring with you in the space. This depends on you. So word matrix in this case, transfer. Cool. So now we are passing inside this system the word matrix. So what we want to do is create us a vector from the position of our vertices and this locator. So we use subtract, and we have our point position subtract with the position of my locator. Now we want to get the axis that we want to. So the way that we are going to work with is with the dot product, and within dot product we can determine if the vertices are in the direction of the axis of our chart, for example x, or not. If the dot product is going to be positive, and depends how much positive, we have on the same direction. If it's not, in the opposite direction. So let's create a value node and choose as matrix. That is fine. Connect. The reason why we want to use the value is because we have access now to the different rows. This determines which axis we want to use. For example, x will be the first one, c1 will be the y, etc, etc. So we go vector 4 to vector 3, and now we can do the dot product between our axis and our vertex direction. And actually this is already what we are looking for. So for example, let's connect directly here. Here we go. So now everything is negative because our locator is we choose x, by the way. So for example, if I rotate, see, now everything is positive. And if you go, here you go. It's simple like that. So you already have a plane activation system with a dot product and a few connections. So first things first, we can get everything here, and that is become a compound, and this can be called dot. Okay, by plane. So we can call by plane. So we can do by plane, and this means because now we can do by radius, for example. So now I just literally decide to connect to see the result. So we have now we have different options. That is the good things. We can have a if condition, for example. With if condition, we choose if we want to have the radius, or the normal value. We can input. So we can input this one. Let's create another input. So the reason why I create another input is just for, let's say, cleanness. I like to have more local nodes instead to go directly on the center on just one all the time, as there is too many connection around it, and I'm not a big fan. By plane, for example. Plane. So now inside our bifrost we have plane true or false. So let's do the default one. True. So now it's true, and this means it's work with the plan. Let's come back on the original things. So let's activate everything, and if you turn on false, you're going to have the normal value here. And or if you like to work with both, you can just do like a multiply. You can multiply our input here with our output, and that will be our result. So now we have our we are going to have our envelope multiplied by our plane. So if I'm here, I can choose the default one, and they work both together. Cool. So let's do the radius example. So this is we don't really use this one at the moment. So what we need to do with the radius, it's very similar. We probably already see this kind of approach in the bulge system, but you know, let's do it. So let's get the inverse matrix. So what we want to do, we want to create localize every vertex position on our matrix position. So let's transform vector 3 to vector 4, or our point. Remember to change the weight on the W to 1. This is very important, or it is not going to work. If you want, I can show you after why. So multi-matrix. So let's multiply our inverse matrix with our point position. So now we have a localized point. Let's come back on vector 3, because we just need to have the vector 3. We don't really interesting to the W. So now we can check the length. In this way we have like because the length of every vertex, then we find it in this way. It's literally like the radius within the point position and my locator. And now we can create, like, we can use set range is in Maya the change range. We can pass the value, we can say from to end, and we go to 1 to 0. So we say 0 to 1 will be our radius, and actually if you want to, this could be even our input. Can be our input. So the reason why I already said that I don't like to do these kind of things because it's become long, but because we are going to create a compound, these two will be very close with each other. So this will be our radius. So what we are doing here with change range, we say, okay, we pass the radius here inside the value. We say from 0, radius 0, so is absolutely in the center, to our final radius. Our value is going to 1 to 0. So we know then when are in the precisely the center, the value will be 1, and it will fade out until like our radius, for example. So that's it. So now we can directly connect with this one, for example. There you go. So now when I go closer, I should have the activation, but I don't, because the radius will be 0. Sorry. But when I connect everything, the radius is by default 0, so of course. So you see now we have the activation. Let's scale it a bit. Let's create a radius a little bit bigger, for example 5. Maybe 5 was a little bit too big, but what I want to show you, like when I go closer, I have my activation. It's cool. And like I say, you can work with the radius, or you even can scale the locator because we work with the matrix, so you can scale it, and this works. If you rotate, of course, you don't see any change because we're working with the radius and the scale, so the position is literally just a position in space. Doesn't really matter the orientation of it. Cool. So like I say, we can get all these things together, and that is going to be our compound, and we can call by radius. Cool. So this is our second one. Now we can start to work with the maps and see the pros and cons of like how to do it. Like I said before, of course you can still do like a condition or multiply. You can work with it. So these are our option, and the way that you combine is literally up to you. So let's say, let's go out this one here. Okay, so now we are just working with the default value. Okay, how to create a map. So the way to so there is a different ways, and I already show you one way with the blend shape, I guess. I want to show you now with the color set. So the way that we can work in this case, we just need to create a color set. I like to create one empty. This is just for us, and we can create how many we want. So the first one would be our default one, color set default, and after that we can create our maps. So this will be a map 1, map 2. I'm working with RGB. I'm going to work with white and black, but because it's RGB, you can use multiple color and you can combine them with, you know, go crazy with that. So now let's create some map. So let's select map 1 and color. Okay. I start with give to the set all color black. So we start to have like all the three maps very empty, and now we can color. So let's do the, sorry, I changed the smooth by mistake. So this will be our first map, this will be our second map, and this will be our third maps, for example. Okay, 1, 2, 3. And of course, the default is the one that we don't want to use. So now we have our so what we want to do now is just get the properties. So get geo property. Just connect the geometry that we want to get the properties. The property would be the name of our map, for example, map 1. So you need to change the type, and you can do it literally like right click, set, and choose it. I do prefer have a value externally. Absolutely no reason to do it. You set default is absolutely valid. Just for me, I think it's just easier to visualize. So that is the only reason why. So connect. Oh, actually, maybe I didn't show you what I did. Vector 3, and I set as an array. So this is map 1. Let's do, for example, directly, so we can see how does it work. So if I go to data directly here, this is not working because this is a color. So we want to go to vector 3 to Scala. Vector 3 to Scala. Let's connect it. And here I'm going to get now the red. So the first one, you can choose whatever you want. And if you see, this is the same map. A little bit rigid, so we can go here and smooth a little bit. So let's smooth a little bit. If you see, everything is in real time and it works. So this is just is the map 1. So let's duplicate it and let's create map 2. So this is work absolutely the same way. So for example, if I change it, that is our map 2. Let's see. Seems pretty okay to me. Same. little bit rigid, so smooth a little bit. Nicer, not nice, but nicer. Let's make it a little bit bigger so we can see better. Okay. Okay. And the same things is with map 3. So this just for the thickness of the this tutorial. We're going short and just show you like the small result, but you know, you can make this one like dynamically, change the name, add written bifrost and add operation. You know, this is the good thing. So this so that is map 3. Like before, it's a little bit 210, so let's smooth a little bit the value. Okay, amazing. So now we get all the three maps, and we are using, so I want to show you. So the thing is, we're using just one target of the blend shape, and we are working with different maps. And like I say, we can, for example, add together. So we want to have map 1 together with map 2. That's it. So we have both. And even if the weights are overlapping, we are not, because we are clamping here. So let's say without clamp, actually let's do clamp 5. Because we're clamping, we have control of what's happening when the two weights are overlapping. And like I say, we can even subtract. So if you want, subtract and connect with this our third map, and now we're removing the third map. Let's see better. So for example, let's add some weight here. You see, we are removing the weights. Oops. Smooth. Okay. So okay, I use the subtract, but for example, I'm not a big fan of subtract. I do prefer to use like everything in one. So for example, in this case, we can create a multiplier with value -1. So we make all this value negative. Connect. So now the third one is negative, so it's mean when we connect we have the subtraction. Here we go. Beautiful. Okay, and that's it for today. So we saw a little bit how to work with the maps and operate with the maps, and what crazy things you can do, or flexible things, not crazy, flexible things. We saw some operation with the transform, like by radius and by plan. And that is just the begin to create a structure, and you can go a little bit further with experimentation. So thank you very much to watch this video. Have a lovely day. Marco.